Surds, rationalizing the denominator. Now, before going on to rationalizing denominators for surds, I'm going to cover a few important points. Let's say if you have root 2 and you divide it by root 2, what is that equal to? Something divided by itself is 1. So if you had 3 root 5 divided by 3 root 5, something divided by itself is equal to 1. The difference of two squares, a squared minus b squared. So this is a squared term, this is also a squared term, and the minus in between meaning the difference. Hence the difference of two squares. This factorizes as a plus b times a minus b. So for instance, let's say if I have 1 minus root 5 times 1 plus root 5. At the moment I've got some surds in here. Now because you've got the same terms but with opposite signs, the same terms with opposite signs, I can simplify like this. The first term squared minus the second term squared. So if I take the first term, the 1, I can square that like this, minus the second term, which is root 5, squared. So 1 squared is just 1 minus, and here the square and the square root cancel to give you this. So 1 minus 5 is minus 4. The reason for using this result is the final answer has no surds in it. It's rational. So we've gone from something that was irrational to something that's rational. Rationalizing the denominator is the process of removing surds from the denominator. So we can have surds in the numerator but not in the denominator. Now if I start with the root 2, so start by looking at the denominator, and the surd in the denominator here is root 2. So I'm going to multiply this fraction by this, root 2 over root 2. And you've seen earlier that something divided by itself is 1. Anything multiplied by 1 is itself. So for instance 5 times 1 is 5. Root 7 times 1 is root 7. So I'm effectively multiplying by 1. So nothing's going to change. The numerical value of 3 divided by root 2 will be maintained. So if you multiply two fractions together, you multiply the numerators together. So 3 times root 2 gives 3 root 2. And you multiply the denominators together. Root 2 times root 2, which is the same as root 2 squared, will just give 2. And as you can see, there's no surd in the denominator here. We have rationalized the denominator. The numerator has a surd, it's irrational. The denominator is rational. So we have rationalized the denominator. 5 root 3 divided by root 2. To rationalize the denominator here, we should keep our focus on the denominator to start with. So based on this denominator, I'm going to multiply my fraction here by root 2 over root 2. So along the top here, root 3 times root 2, so 3 times 2 is 6, so that gives root 6, which cannot be simplified, times the 5, over root 2 times root 2 is 2. So once again, the denominator is a rational number. We have rationalized the denominator. If you're wondering why you're doing this, well, in the days before you had access to calculators everywhere, if you were doing 5 root 3 divided by root 2, that would be very difficult to work out. It's less difficult to work out 5 root 6 divided by 2. Okay, if you're dividing by a third, it's hard, and dividing by a whole number is much easier. Rationalizing the denominator. Looking at the denominator first, the third is a root 7, so ignore the 5 there, just the third, root 7. So I'm going to multiply by root 7 over root 7. So I'm effectively multiplying by 1, because root 7 divided by root 7 is 1. So multiplying the numerators, so that's 2 times root 7, and then multiplying the denominators, root 7 times root 7 is just 7, and 7 times 5 is 35. Okay, so I'm multiplying like this. Root 7 times root 7 gives 7, and that 7 times 5 is 35. So once again, the denominator has been rationalized. Now, in the examples that we've looked at so far, the denominator is just a single term. Now we're going to go on to rationalizing denominators, where you have 2 terms in the denominator. So in this fraction here, we have surds. The surd is in the denominator, and we need to rationalize the denominator. So I need to modify this so that I end up with something which does not have a surd in the denominator. And once again, I'm going to multiply this by something, but this time, because this is more complicated, I'm going to use the difference of 2 squares. So the same terms, just copy them over, 3, and there's the root 5, but with the opposite sign. That's a minus, I'm going to put a plus here. Now what I'm multiplying by should be equal to 1, so I need the same terms in the numerator. So now I need to multiply out both sides. So using the difference of 2 squares, so if I've got something, well, in this form, that's going to give a squared minus b squared. I'm going to use this to multiply the denominators together for both fractions. The numerator is just 2 times the 3 root 5, so it's 2 times all of this. And the denominator, if I take the first term, which is the 3, that's taking the 3 and square it, minus the second term squared, so that's the root 5 squared, and then simplifying this, let's start with the denominator. 3 squared is 9, root 5 squared is 5, because the square root and the square cancel. We've got this, and the numerator, 9 minus 5 will give 4, and then I can cancel the 2 with the 4. So the final answer will be 3 plus root 5, because 2 over 4 is just the half, so there's your half. I'm dividing by 2. Okay, next example, 5 divided by root 3 minus 1, so I need to multiply by something that's equal to 1, so the top and the bottom here must be the same, and looking at the denominator here, I'm going to use the difference of two squares because I've got two terms here. So same terms as here, but with the opposite sign. That's a minus, this will be a plus. So for this fraction to be 1, the top must be the same as the bottom. These must be the same. And now multiplying the numerators together gives this. And along the bottom we've got the difference of two squares. So take the first term and square it. So there's root 3 squared. And it's the difference of two squares, so that's going to be a minus. Take the second term and square it. And now we can simplify all of this. So starting with the denominator here, root 3 squared. The square root and the 2 cancel to give you 3. Minus 1 squared is just 1. So 3 minus 1 will just give 2. And the numerator, 5 root 3. 5 times root 3 is 5 root 3. 5 times 1 gives 5. There you go, rationalized. The denominator is now without surds. Here we have a fraction that has surds in both the numerator and the denominator. So I need to multiply by something that's equal to 1. So the top and the bottom must be the same. So start off by looking at the denominator. We've got two terms, which means I'm going to use the difference of two squares. So I'm going to multiply by root 3 minus 2. Same terms, opposite signs. So the top must be the same as the bottom here. And now I'm going to multiply these numerators together and these denominators together. Now multiplying the denominators is just the difference of two squares. So take the first term, which is root 3, and square it. The difference, the minus. Take the second term, which is 2, and square that. There. Now along the top, this is more complicated. You need to multiply 2 minus root 7 by root 3 minus 2. So we multiply every term with every other term. 2 times root 3, 2 root 3, 2 times minus 2, minus 4, minus root 7 times root 3. That's a negative number multiplied by a positive number, so you will get a negative value here. Multiplying two surds together, so if I'm doing this, 7 times 3 is 21, I'll get root 21, and root 21 cannot be simplified any further. So minus root 21, and last of all, the minus root 7 times the minus 2. A minus times a minus, which gives you a plus. Root 7 times 2, 2 root 7. The numerator will not simplify. That's a root 3 term. This is a root 21 term. This is a root 7 term. They're all different. You can't simplify these. The denominator, root 3 squared, or the square root and the square cancel to give you 3, minus 2 squared is 4. 3 minus 4 gives minus 1. So I can simplify this by writing it like this. Now if you divide anything by minus 1, what you're doing is you're changing the signs throughout. So that becomes a minus 2 root 3 plus 4 plus root 21 minus 2 root 7. And you may want to write this with the whole number first. So 4 minus 2 root 3 minus 2 root 7 plus root 21. So this is the final answer.